4.4, Evaluating Logarithms and the Change of Base Theorem. We start with the common log, and the common log is just the log base 10. And that's going to be useful when you see the log button on your calculator. That's the common log, that's log base 10. Example 1 says use a calculator to find these values. So when it's a log, just a regular log, we assume that it's a log base 10. But this is what we're looking at. When you see the log button on your calculator, you can just type it in. This is the only base where you can do that. Log of 10,000 is 4. Now remember, the answer to a log is the exponent. So if you think about it, if that's a base 10, it's like saying what exponent would give you 10,000. Part B, I'm just going to type in log 341. 2.5328. Let's round off. 2.5328. And then this one, log 0.06894. Negative 1.1615. I like rounding off to 4 decimals, but just make sure you follow the directions and round off to whatever they tell you to round off to. Note base A logarithms of numbers between 0 and 1, where A is greater than R, always negative. Here's an application. We talk about pH and acidity. So we've got this formula, pH equals negative log of the hydronium ion concentration, H3O positive. 2a says find the pH of a solution with that H3O positive, that hydronium ion concentration of 6.8 times 10 to the negative 8th. So look at your equation. The pH level is equal to the opposite of the log of that number, 6.8 times 10 to the negative 8th. So remember what happens when we multiply times 10 to the negative 8. The decimal moves 8 times. 1, 2, 3, 4, 5, 6, 7, 8. That's going to put 7 zeros in there. So the pH is going to equal the opposite of log of point and then 7 zeros with a 6/8. And so really it's just a calculator question at this point. Negative log 0.1, 2, 3, 4, 5, 6, 7, about 7.2. So the pH is about 7.2. Example 2b, find the hydronium ion concentration of a solution with pH equal 4.3. So that one goes backwards. So they give you the pH, so they're giving you the left side of the equation. And they're asking you for that H3O positive. So to do this one, what we're going to have to do, we're going to have to divide by the negative to get rid of that. So negative 4.3 equals the log. We're basically trying to isolate x here. And so I'm not sure if we've done this yet or not, but in order to isolate this, you have to get rid of the log. And remember, this is a log base 10. And the inverse operation of a logarithm is an exponential. I know we've talked about that. And so in order to cancel out that log base 10, we're going to do a base 10 exponential. So x is going to actually equal whatever 10 to the negative 4.3 power is. (10 to the negative 4.3 power gives us, notice that says 5.01 e negative 5. That means times 10 to the negative 5th. So your x, or in this case your H3O positive, your hydronium ion concentration, is about 5.0 times 10 to the negative 5th power.